Okay everybody, welcome to another course from linuxhint.com YouTube channel. This entire course is free and we have created it from this one of the amazing books ever written on Linux programming, and the title of that book is The Linux Programming Interface, a Linux and Unix System Programming Handbook. So we would try to cover most of the topics in a brief way. Each topic is a chapter from the book, and in some cases each topic is a combination of two or more than two chapters as well. So the code examples that are given in the book, we are not going to use those code examples. Instead, we will use other code examples. Also, the book is 1500 pages long, so it is not possible to cover this whole book. This video is long, but still we are just barely scratching the surface. So what we recommend you, what you can do is that you can buy this book from the link in the description and watch this whole course for a better understanding, along with actually reading and reviewing the book yourself. So we wish you best of luck, and now let's start. Okay, so the first topic is introduction. So in introduction topic, I'm just going to tell you that what is the significance of programming and what it actually does. So the idea is that the your computer basically understands only binary digits. So it communicates in zeros and ones. Okay, so if you were to ask that what is the language of a computer, so it appears to be something like this. Okay, 0 1 1 0. All right, so the idea is that you cannot really understand it no matter how smart you are, but the smart people who are, you can say, a little bit smarter, they have introduced a framework. Okay, so they developed a programming language which has a specific syntax, and that syntax basically you program it, you write a few commands, and what it does, that compiler, it basically converts that code that you have written into zeros and ones. Okay, and then those zeros and ones basically communicate with the computer. Okay, so that's how basically it kinds of works. So I'm going to repeat it once again. So the idea is that you write a program, the C program essentially, that we are going to write in a while, and then that program basically is converted into zeros and ones, you can say, in the binary, and it is converted by the compiler. Okay, essentially, and then it's basically sent to the computer, the processor, which understands this binary language, and then it executes the command, whatever you have said. For example, you have said hello world, printf hello world, and then in that case what's going to happen, that it is going to convert, the compiler is going to convert the code in binary digits, zeros and ones, and then these zeros and ones will be communicated with the processor, and then the processor will execute the command, and it would print out hello world on the screen. Okay, so the next topic is related to file input and output. So the idea is that in order to perform input and output on a regular file, we must first obtain a file descriptor using open, or we can use fopen as well, and in that case we'd use pointer. So the idea is that file descriptor is something that you use by using integer digits. So if you use 0, then it means that you're using that descriptor known as standard input, stdin, and if you are using the digit 1, then you are basically using standard output, or stdout, and if you're using the digit 2, then in that case you're basically using the standard error, or stderr. Okay, so after that, after using the open or fopen, you then perform the IO, or input output function, on a file using read and write function. So the idea is that function is basically something which is which was built in order to avoid the repetition of the code. So the idea is that, let's say if there are like hundreds and thousands of lines of code which are meant to be repeated inside code, then in that case what you would do, that for that, let's say 100,000 lines, instead of copying them over and over again, you just basically create a function, and inside that function you paste those 100,000 lines, and then you basically just call that function like this, okay, like write or read or whatever that function might be. So in one line you would be calling those 100,000 lines, okay. So that is basically the power of function. So that's what we're going to do. We're going to use write and read functions in this examples. So after performing all input output, all kind of functions, we should free the file descriptor and its associated resources using the function close that we will also use, close or fclose. For each open file, the kernel maintains a file offset which determines the location at which the next read or write will occur, okay. So the file offset is implicitly updated by reads and writes, and you can also use the seek function that we are going to use. We can explicitly reposition the file offset to any location within the file or past the end of the file, okay. So writing data at a position, at a specific position beyond the previous end of the file, creates a hole in the file, okay. So we can cover that by using IOCTL function. That's mentioned in the book, so you can read the book for further details on that. So let's go ahead and let's try to do some practical examples. So before jumping into that, we'll discuss a few things, okay. So the idea is that you can ask that why do we need the files, okay. So the answer to your question is that when a program is terminated, the entire data is lost, okay. So storing in a file will preserve your data even if the program terminates, all right. So if you have to enter a large number of data, it will take a lot of time to enter them all. So however, if you have a file containing all the data, you can easily access the contents of the file using few commands in C language, okay. So you can easily move your data from one computer to another without making any changes. All right, so there are basically two types of files. One is the text file, the other is the binary file. So this is the basically text file that you are familiar with. Binary file, in binary file you have, this is .bin file, in which you have zeros and ones, which is not easily understandable, and obviously it stores more data than text files. Text files you know, it takes more space, but bin files take less space and it stores more data. And obviously the bin files are secure, in fact you can say more secure in comparison to the text files, okay. I hope you've got the point. So there are four kind of file operations that you can perform in the C programming language. Number one is that you can create a file. Number two is that you can open an existing file. Number three, you can basically close a file. And number four, basically you can read and write inside the file, okay. So these are four main you know, functions or operations that you can perform, okay. So the idea is that in order to work with the file, we always need pointer or descriptor, okay. So in this example, the example that we are going to do, in this example we are going to use pointer, while the example that is mentioned in the book, they have used descriptor, okay. So our examples are entirely different, so we have not taken any example, we are not using any example from the book, okay. So first of all, basically in order to write the C code, you need to open up your terminal. You press Ctrl Alt T and you check if the C version is installed or not. So let's say you write here GCC and then you write double hyphen and then you write version and then you hit enter. So you can see that basically we have this C programming language GCC version installed. So let's say if you do not have that and it doesn't recognize that, in that case you are going to write here sudo apt get install and then you're going to write here build essentials, okay. That is the simple command you're going to write if in case this GCC command, it doesn't recognize it and you don't have it inside your computer, okay. So the next step is basically you can create a file, a C file, and then you can basically run it, okay. So the idea is that in other compilers like C compiler and the turbo compiler, you just have a compiler in which you read the, basically you write the code and then you run it and then you get the result. But in here using GCC, we are going to run our program differently. it is going to create a binary file in which we would have the result. Okay, so let's see how do we do that. So first of all, we're going to create our C file. So in order to do that, we'll go to our desktop. So we write here cd and we write here desktop and we go here. So now we just clear it. So in here now we are going to create a file. Okay, so we write here touch and then we write here C program.c. okay, so C program would have a .c extension. So right now this file is basically empty. So obviously if we would run the empty file, we'd get an error. Okay, so in order to run a C file, what you have to do is that you have to write here gcc, and then obviously we know that this file has nothing in it, so it's gonna throw an error. So the purpose to run this file here is that you should know that this thing is working. Okay, so -o, and then you basically write here test, which is a binary file which would be created, and you can see that it gives us an error, that undefined reference to the main. Basically we don't have anything inside of it. Okay, so instead of writing an example program, we just go ahead directly and we would start working with the files. All right, so let's say that first of all we try to open a file. So we have different file modes for different kind of files that I would explain in a moment. So the idea is that first of all, in order to write a text file using fprintf, that's what we're gonna do. So the idea is that in order to write the file, we are going to use stdio.h libraries. So we are just going to write here hash include, and then we're going to write here stdio.h. okay, and then there is another library that we're going to use, include. So in programming, the libraries are the essentially the built-in sort of classes and built-in programs that you can use, with the help of which you can use the built-in functions. Okay, so we'd write here stdlib.h. okay, and then we come here, we create the main function using int main, and then inside of that what we are going to do is that we're going to write here int number. Okay, and then we're going to write here file, and then we're going to write here steric fptr, which is basically a pointer. Okay, you can also use descriptor here. In example, they have used the descriptor, and then you can basically write here fptr. You can use this pointer, and then you write here, then you use fopen function here, and in here you basically give the path of the file. So let us just create a random file. Let's say you don't have this file right now. Let's say we name something, some file that doesn't exist. So what it would do, that it would basically create that file for you. Okay, that's what I think, but let's see what happens. Okay, so I have now what I'm gonna do, I have written this fopen function, and in here I'm gonna write here the file name. Let's say I call it file1.txt, and I give it a mode as W. Okay, so W is basically a mode. So the idea is that there are different modes. So W is for writing, R is for open for reading, RB is for open for reading in binary mode, WB is for open for writing in binary mode, A mode is for append, AB is for append in binary, R plus is for open for both reading and writing, RB plus is basically for binary reading and writing, W plus is for open for both reading and writing, WB plus open for both reading and writing in binary mode. So there are other A and AB plus as well. So there are different modes. So we are using just W, which is for writing inside the file. So then